Hello and welcome back to another video for differential equation, and this time we are solving linear differential equation with constant coefficient. So this particular video would focus on the particular solution of linear differential equation with constant coefficient, and particularly also in the topic of distinct roots. So we have here an auxiliary equation. We can derive the auxiliary equation here. The auxiliary equation would be m squared minus 2m minus 3 is equal to 0. So for this auxiliary equation, we will factor this out to solve for the roots. So this would be 3, this would be 1. So ito negative, this will be positive. So therefore, the roots here are negative 1, m sub 1, and m sub 2 would be positive 3. So now that we have the roots, we can go to the solution. And the solution to our differential equation, general solution, would be c sub 1 e raised to negative x plus c sub 2 e raised to 3x. Now we have to find the particular solution that when x is 0, y is 4, and y prime is 0. So first case, when x is 0, y is 4. So we have 4, let's substitute y for 4, and then c sub 1 e raised to 0 plus c sub 2 e raised to 3 times 0 is still 0. So we have the equation. So e raised to 0 is 1. So 4 is equal to c1 plus c2. This will be your equation number 1. Another given here for the condition is when y prime is taken, it would be equal to 0. So let us get the second derivative of our solution, general solution. So we'll have y prime, then this will become negative c1 e raised to negative x plus 3c2 e raised to 3x. Okay, and then let's substitute the case that when y prime is 0, of course, no, it would still hold that x is 0. Okay, so let's solve for that. So this one would become, so we have y prime is 0, and then minus c sub 1 e raised to, so negative x, so that would be still 0, plus 3c2 e raised to 3 times 0, so 0 pa rin yun. So we'll have 0 is equal to, so this one will become c1 plus 3c2, and this will be your equation number 2. So what we can easily do here is to add equation 1 and equation 2, because we have here c1 is positive and we have here c1 is negative. So if we add them, so 4 is equal to c1 plus c2. This is your equation number 1. And if you add them together, c1 will be cancelled out. Okay, so you'll have 4 is equal to, so this one is cancelled out, and you'll have 4 c sub 2, and therefore c sub 2 would be equal to 1. Okay, and then last, we can solve for c sub 1 using either equation 1 or equation 2. So let's just say I use equation 1. So we have 4 is equal to c1 plus c2, and c sub 2 is equal to 1. So therefore c sub 1 would be equal to 3. Okay, now we could verify the two arbitrary constants here if I will use equation number 2. Okay, so we have 0 is equal to negative c1, so that would be negative 3, okay, plus 3c2, so 3 times 1, so that would be equal to 3, and therefore it would fulfill equation 2. So the particular solution in this case would now become y is equal to, so we have c1 is 3, so 3 e raised to negative x plus c sub 2. C sub 2 is 1, so e raised to plus e raised to 3x, and that would now be the final answer and the particular solution of this differential equation. Let's go to the next problem. Problem number 2, we have quantity d squared minus d minus 6 times y is equal to 0. And we have to solve the particular solution when x is 0, y is 0, and also when x is 1, y is equal to e raised to 3. So just for clarification na lang din, this particular differential equation is in terms of differential operators, and if this would be rewritten, it would be y double prime minus y prime minus 6y is equal to 0. Okay, so the first step that we want to do is to determine the auxiliary equation, and the auxiliary equation is simply m squared minus m minus 6 is equal to 0. And then let's solve for m. So we have m there, and then we'll have 3 and 2. Okay, so to make it negative and the middle term negative, the 3 will have the negative sign. Okay, and this will be positive. Okay, so you'll have m1 is equal to negative 2, and m sub 2 is equal to negative 3. So we can go ahead and write the particular solution. Particular solution is y is equal to, so we have c sub 1 e raised to, so by the way, this should be positive 3, okay, because this is negative 3. So if you equate it, m minus 3 is equal to 0, so m sub 2 is equal to 3. Okay, so you have y is equal to c sub 1 e raised to negative 2x plus c sub 2 e raised to 3x. Okay, so that is your general solution. Now, for the particular solution, first we have x is 0. When x is 0, y is 0. So let's substitute that. We have, let's write it down first. X is 0, y is 0. Okay, so y is 0, so we have 0 is equal to c sub 1 e raised to 0 plus c sub 2, again, this would be e raised to 0. So you'll have 0 is equal to c sub 1 plus c sub 2. Or simply, c sub 1 would be equal to negative of c sub 2. Okay? In the next case is that when x is 1, you have y is equal to e raised to 3. Okay? So, we substitute y with e raised to 3. So, we have e raised to 3 is equal to c sub 1 e. So, if this is 1, so that would be e raised to negative 2. And then plus c sub 2. Then x is 1, so this would be e raised to 3. Okay? Times e raised to 3. So, you have two equations. This is the first equation. Equation 1, and this is your equation 2. Now from equation 1, I've said that C1 is equal to C sub 2. So we could simply substitute that. Okay, substitute equation 1. Substitute equation 1 to your equation 2. So konting algebra na lang to, guys. So we have e raised to 3 is equal to c sub 1, that would be negative c sub 2, e raised to negative 2 plus c sub 2 e raised to 3. So from the left side, you can factor out c sub 2, and you'll have e raised to 3 minus e raised to negative 2, and this one retains to be e raised to 3. And then finally, c sub 2 would be equal to e raised to 3 minus e raised to negative 2 over e raised to 3. And that could be simplified as e raised to 3 over e raised to 3 minus e raised to 2 over e raised to 3. Okay, so c sub 2 would be 1, and then this one would be minus e raised to negative 5. Okay, so if that is your c sub 2, then therefore c sub 1 would be the negative of that. So you'll have e raised to negative 5 minus 1. Okay, so substitute that to our given to get the particular solution, or substitute that to the general solution here. So for the general solution, let me copy that. So this is now our general solution that we have obtained earlier. And we have obtained these two particular values for c sub 1 and c sub 2. But we have made a statement a while ago that c sub 2 would be equal to the negative of c sub 1. So if we will apply that here, before we substitute, let's just apply that fact here. So we have c sub 1 would be equal to the negative of c sub 2. Let's say I factor out c sub 2. I choose to factor out c sub 2 later. So this would be negative 2x plus, that would be negative 2x, okay, plus c sub 2 e raised to positive 3x. So I can now factor c sub 2, and I'll have e raised to 3x minus e raised to negative 2x. And simply substitute c sub 2. So I will now have as my final answer 1 minus e raised to negative 5 quantity times a quantity e raised to 3x minus e raised to negative 2x. And that would be the particular solution. So let's go to the next problem. Problem number 3. We have quantity d cubed minus 4d plus quantity y times y is equal to 0. Okay? And we have to find when x is 0, y is 0, y prime is 0, and y double prime is equal to 2. And we have to find the specific case, find y when x is equal to 1. So not only are we to find the particular solution based on this case, but after solving for the particular solution, we have to find the value of y when x is equal to 1. Okay, so let's proceed. We have the auxiliary equation would be m cubed minus 4m is equal to 0. So first we factor out m. So we have m squared minus 4. And we can factor out m squared minus 4 as m plus 2 times quantity m minus 2. So the values of m would be, first, we have m sub 1 is equal to 0. M sub 2 is equal to negative 2. And m sub 3 is equal to positive 2. Okay, so what would be our general solution? So we have y is equal to c sub 1 e raised to 0x. So 0x, so 0 na rin yun. Or later on, magiging 1 yan. Plus c sub 2 e raised to negative 2x. Plus c sub 3 e raised to positive 2x. So simplify, of course, as I've said, e raised to 0 is 1. So we'll only have c1 plus c2 e raised to negative 2x plus c3 e raised to positive 2x. Okay? So that is your general solution. Okay? Now we have to solve for c sub 1, c sub 2, c sub 3 using the boundary condition here. So first, we have x is 0. When x is 0, y is 0. Let's write it down. X is 0, y is equal to 0. So we have 0 is equal to c1 plus c2. So this will be e raised to 0 is 1. And then again, this would be e raised to 0. So that would be c3. So we have here our first equation. 0 is equal to c1 plus c2 plus c3. Okay? Now, next we have y prime is equal to 0. So in order to properly substitute for that, we have to get the first derivative of our general solution. So we have y prime is equal to, so c1, derivative of a constant is 0. And this one will become negative 2 c2 e raised to negative 2x plus 2 c3 e raised to 2x. Okay? And then when y prime is 0, so when y prime is 0, this particular point, x is 0. So at x is equal to 0, your y prime is 0. Okay? So x is still equal to 0 when y prime is 0. Remember that. That's similar to problem number 1, I think. So we have y prime is 0, negative 2, c sub 2 e. So since this is 0, so that would be e raised to 0 plus 2 c sub 3 e raised to 0 again. So if you simplify that, you'll have negative 2 c sub 2 plus 2 c sub 3. And we can actually divide by 2 or multiply 1 half, and we will have 0 is equal to negative c2 plus c3. Okay, and that would be our equation number 2. Okay, so we have equation 1 and equation 2 here. Next, we use this particular case, y double prime is equal to 2. Again, we can still use at x is equal to 0, no, y double prime is equal to 2. Okay, so for us to solve for that, we have to get the second derivative. So we have here the first derivative, so therefore we can just continue and solve for the second derivative. So we'll have 4 c2 e raised to negative 2x plus 4c3, okay, 4c3 e raised to 2x. Now when y double prime is equal to 2, x is 0. Okay, let's write it down. Y double prime is equal to 2, x is 0. So this will be 2 is equal to, so again, these two terms, two exponential terms will be equal to 1. So we'll simply have 4c sub 2 plus 4c sub 3. We can multiply 1 half, and this will become 1 is equal to 2c sub 2 plus 2c sub 3. And this will be your equation number 3. Okay, so let's review. We have equation 2, negative c2 plus c3. Actually, we could further simplify this as c sub 3 would simply be equal to your c sub 2. Okay, and then we have equation 1, wherein c1 plus c2 plus c3 is equal to 0. Okay, so what we can do there actually is to first simplify using equation 2 and equation 3. From equation 2, we have c3 is equal to c2. So we can just substitute, no? c3 equals c2, and this is from your equation number 2. Okay, so substitute that. 1 to equation 3 is equal to 2c2 plus 2 times c2 again. Okay, because c3 is equal to c2. So we have 1 is equal to 4c2, and c sub 2 would be equal to 1/4. Okay, and of course, c sub 3 is also equal to 1/4. No? From equation number, that would be from equation number 2. Now, the only thing left is solve for c sub 1. So from equation 1, we have c1 plus c2 plus c3 is equal to 0. Okay, so we have 0 is equal to c1 plus c2 plus c3. So 0 is equal to c1 plus c2 is 1/4 plus c3 is also 1/4. So 1/4 plus 1/4, that would be 1/2. Therefore, c1 would be equal to negative 1/2. Okay, now that we already have our c1, c2, and c3, okay, we can now solve for our particular solution. Okay, so what is our general solution? Our general solution is what? Let me again just copy this. Okay, copy that and paste it here. Okay, so that is our general solution. We are now ready to substitute the arbitrary constant that we have solved. So we have y is equal to c1, so we have negative 1 half, plus c2, so that is 1/4, e raised to negative 2, e raised to negative 2x, plus c3, so 1/4 e raised to positive 2x. Okay, so beforehand, we always eliminate the fractions, but this time just let it be. Let everything be simply equal to y. Okay. Another way of rewriting this particular solution is that if you realize that this is actually equivalent to a hyperbolic function, but if you do not, no, if you encounter this and you do not realize that, then that's fine with me. Okay, so notice here you have 1/4 e raised to 2x and 1/4 e raised to negative 2x. Okay, now that 1/4 can be written as 1/2 e raised to x quantity squared. 1/2 would be the middle term, and plus 1/2 again e raised to negative x squared. So what we have here is a perfect square trinomial, wherein we can simplify this as simply 1/2 e raised to x minus 1/2 e raised to negative x quantity squared, because it's a perfect square trinomial. If you have realized that, now this is the middle term, uh, this is actually a squared minus 2ab, okay, minus 2ab plus b squared. Okay, now this term right here, or the terms right there, could be simplified further as e raised to x minus e raised to negative x all over 2 and then squared. Now it is equivalent, no? Let us review. The hyperbolic sine function of x is equal to e raised to x minus e raised to negative x over 2. So the particular solution, my point is, the particular solution can also be written as the square of the hyperbolic sine function. Okay, hyperbolic sine function of x. So that would be more simple, but if you're not familiar with the hyperbolic sine function, then it's fine. So the next part of our problem, so these two can be considered. No? I will consider those two as your particular solution. Now, our problem, as I mentioned in the first part, no, has another unknown. Find y when x is equal to 1. So that would be very simple. No? What is y when x is equal to 1? So the answer is y is equal to the hyperbolic sine of, we simply substitute x and x is equal to 1. So we simply have to solve for that. Okay, and if we get our calculator, okay, so we have 1, then let's get the hyperbolic sine of that. Okay, 1.17 and square it. Okay, so that would be equal to 1.38. Okay, and that would be the final answer. So I hope you've learned something with this video, and I focus here on getting the particular solution of the differential equation, linear differential equation with the constant coefficient, having an auxiliary equation that is having an auxiliary equation with distinct roots. So again, thank you for watching.